Okay, so question 3 just asks, what is the molar solubility of a compound C2D3 given its solubility product constant? Ksp is equal to 9.4 times 10 to the negative 9. Okay, so first let's just define what molar solubility is. So molar solubility is the number of moles of solute that can be dissolved per liter of solution. And then this is before it becomes saturated. So you know a solution starts to become oversaturated when a precipitate starts to form. So there's going to be a moment where you have a concentration of solute that is greater than the molar solubility, and when you start to add more of the solute, then it's not able to dissolve in the amount of solution that you have. So that's why its precipitate starts to form, and you can start to see a solid in the solution. Okay, so back to the example. They just had a general compound, CD2-3. So this isn't like a real, like, these aren't real elements or anything, but we're going to try and write out what this compound would look like if it was broken up into its ions. So if we had C2D3 solid, it will break up into 2 C3 plus ions and also 3 D2 minus ions. And the reason I know the charges as well is because I just did because we know that we have C2C atoms in the compound, so we needed 2 of these atoms to neutralize 3 of the D atoms. So if you kind of cross the numbers over, then that's how we know what charges they are. So the C has the subscript of D as its charge, and it's a positive charge. And then the D has the subscript of C, and its charge is negative. Okay, so the question also gives us the Ksp value, which is equal to 9.4 times 10 to the negative 9. Okay, so first we're just going to make an ice table. And we can just cross out the column of our reactant since it is a solid. And we're just going to be looking at our ions. So the initial concentration of both of the products is 0, since we start off with 0. And then the change will be plus 2x, and for D, it is plus 3x. So it depends on the coefficient in front of your ions in the balanced chemical reaction. So this shows us that our concentration at equilibrium is equal to 2x for the C3 plus and 3x for the D2 minus. Okay, so now we can write our Ksp expression. So for this question, Ksp is equal to the concentration of 3 plus to the power of 2. Again, this also depends on our balanced chemical reaction. And our concentration of D2 minus is going to be to the power of 3. Okay, so now we can plug in everything that we know. We know our Ksp value is 9.4 times 10 to the negative 9. And we also know the concentration of our C3 plus should be equal to 2x, and this will be squared. And our concentration of D2 minus should be 3x, and this will be to the power of 3. Okay, so we can simplify this in order to make it easy for us to solve. So it's going to be 4, 27, so 27 times 4, 108x, and then when you multiply exponents, you just add the values together, so you get x to the power of 5. Okay, so let's divide both sides by 108. And you should get 8.3 times 10 to the negative 11 is equal to x to the power of 5. And now we just do the power of 1 over 5 for both sides, which gives us an x value equal to around 0.0096. Okay, so this is the molar solubility of the compound. Okay, so the junior tutor said, in definition, solubility or molar solubility of a compound is the concentration of the dissolved solids in a saturated solution. Molar solubility can be solved using the given solubility product constant. For the compound C2D3, we can express this as a concentration of C and D in the aqueous solution. Solve for the molarability. Let S equal the molar solubility of C2D3 in moles per liter. Concentration of C is equal to 2S, and the concentration of D is equal to 3S. Substituting this to the solubility product constant Ksp formula, we'll have 9.4 times 10 to the negative 9 is equal to, I think they just forgot to put the squared and the cubed in the question. But this should read 2s squared times 3s cubed. And then they just solve for their s, but I'm just going to add that what they should have wrote instead. Okay, so I'm not going to write all of the mathematical steps, but I just wrote that the explanation is correct. However, the Ksp formula should be Ksp is equal to C3 plus to the power of 2 multiplied by D2 minus to the power of 3. And then I showed what the expression should look like. Let me try to put this in square brackets. Maybe it'll be easier to read. I might as well write the next line to make it a little more clear. Okay, so now we can move on to question number 4.